All right, students. This week we're going to talk about function notation, and we're going to keep going on that. So we have to remember, so that f of x, that's how you say that, f of x equals y. So x, so this is like the machine, that like the expression, the equation that you've been working on. And if you put an x value into that machine, you get the f of x equals y, which you get the result, which is y usually, right? So the letters f, x, and y are commonly used to name functions, okay? So for example, since the equation y equals 4x minus 3 describes a function, we may use function notation f of x equals 4 times x minus 3. So we say f of x, this right here, f of x, okay? And that's function notation. So for functions, the notations y and f of x can be used interchangeable. So interchangeable. So you can use, so y and f of x are the same. They're equal to each other. So notice that this equals that. That means that it's equal. So you can either say y or you can say f of x. So for the function defined by f of x equals 4 times x minus 3, if x equals 2, then f of 2. So what you're going to do is that you're going to plug in that 2 for x, right? So that would be 4 and then times 2 minus 3. So the statement f of 2 equals 5. So let's find it. So that's 4 times 2, that's 8, minus 3, that's 5. See? So the f of 2 equals 5 says that the value of y is 5 when x is 2. So we plugged in that 2, right? And we got 5. So f of 2 equals 5. The statement f of 2 equals 5 also indicates that the point 2, 5 lies on the graph of x. So this is x, right? And this was my y. So that means that this point will be in that equation, in that graph, in that function, right? So that's what all this function notation means. All right. So let's do some examples. So evaluating functions. So when you see this, we said that these will be the value for x, right? So g of -1, g of -2, g of 0, g of 5. They're giving you the value of x. So the function is g of x squared minus 5 times x plus 2. So what you're going to do, we're going to use this function and plug in this input. So let's do that. So we have x squared minus 5x plus 2. And we're going to substitute that x for -1. So that's -1 squared minus 5 times -1 plus 2. And then just solve. So that's 1 plus 5, 1 plus, oh, that's a 4. 1 plus 5 plus 2, that's 1 plus 5, that's 6 plus 2 is 8. Because -5 times -1 is +5, right? Okay. Now, same thing here. We have same function, right? So x squared minus 5 times x plus 2. And plug in that -2 here. So g of x, g of -2. So that's -2 squared minus 5, -5 times -2 plus 2, and then solve. So simplify. So that's 4 here. That's plus positive 10 plus 2. And then you get 14 plus 2 is 16. So that is that. Okay, so when x is -1 in this function, you get here 8, here you get 16, and let's try 0. So that's x squared minus 5x plus 2, and then substitute x for 0. So that's 0 squared minus 5 times 0 plus 2. Well, I get equals 2 because that's 0 and that's 0. So when g of 0 is 2 equals 2. And then same thing for 5. So we have 5 squared minus 5 times 5 plus 2, that is 25 minus 10 plus 2, and that's 25 minus 10, that's 15 plus 2 is 17. So when x is 5, g of x is, so y is 17, or g of x, right? All right, so we're gonna do the same thing here and the same thing here and then the same thing here. So it's just substitution, right? So I'm gonna do one of these and then one of these so you guys can follow. All right, so we have the same thing. So now the function is f of x, and then they're telling me that f of negative 3. So what is f of negative 3? I'm just gonna plug in for x here. So that's 2x squared plus 2, and then x is negative 3. So that's negative 3 squared plus 2. So that will be positive, right? So negative 3 times negative 3, that's 9, and 2 times 9 is 18. So 18 plus 2 is 20. Same thing here. That would be with the same function. So that's 6 squared times 2 plus 2, that's 36. 36 times 2 is 72, that's 74. So, and so on. That's what you do here. And same thing here, you get the point. So I hope this helps. So it's mostly substitution here. What it is important about this week is basically the notation. And know that y equals f of x. In this function, it would be the same thing as saying this. Okay, so I hope this helps.